Hey everyone, welcome back to Math Learning Hub. I'm Chanya and I'm going to be teaching you cool things about Pascal's triangle. So basically, if you don't know, Pascal's triangle is something that looks like this, where this row is row 0, and this goes row 1, row 2, all the way down, right? And Pascal's triangle keeps going on down. And the way it works is that each number is the sum of the two numbers above it. So with the exception of the first two rows, this just starts with 1 and then 1, 1 over here. But as you can see, if you have like 2 over here, 2 is 1 plus 1. If you have 4, 4 is 3 plus 1, etc., etc. So you can see it's symmetrical and it does have some really nice properties. So if you're coming here for TMSCA, the main property that you would need to know is how to sum the numbers in each row of Pascal's triangle. And that might seem simple, right? If you're looking at row, for example, 2 or 4. But as you go down, the numbers get bigger and bigger, and it becomes more tedious to sum the entire row by hand. So what we're going to do now is derive a pattern. Okay. So we're going to derive this pattern by looking at the sums of the numbers from row 0 all the way down. So what's the sum of the numbers in row 0? Where there's just one number in row 0. So that's just going to be 1, right? What's the sum of the numbers in row number 1? Well, that's 1 plus 1, which is equal to 2. What about row number 2? 1 plus 2 plus 1 is equal to 4. And then row number 3, this is equal to 8, and then 16. And you can keep going down the line here, but if you notice, we can see a pattern here. 1 is equal to 2 to the power of 0, 2 is equal to 2 to the power of 1, 4 is equal to 2 to the power of 2, 2 to the power of 3, and 16 is 2 to the power of 4. And as you notice, this actually corresponds with the row numbers. This is row 0, 1, 2, 3, and 4, right? So as you can see, we saw a pattern here. So the sum of the numbers in row n, this formula is going to be 2 to the n, where n starts from 0 at the first row here. And that is basically all you need to know for TMSCA. Just remember, if you're doing the sum of the numbers in row number 10, for example, that would just be 2 to the 10 or 1024. So that's an easier way to calculate the sum of the numbers without actually having to summing them. However, I am gonna go into more of an advanced topic, and that's binomial coefficients. And what I mean by this is you don't need to know any of this for TMSCA, but it's just like a really interesting fact about Pascal's triangle. So if you remember the formula for a plus b squared, where I did go over this in another video, and you can like search, I think it's called sum of squares. Yeah, I think it's called like squaring techniques or something like that. But if you have a plus b squared, this is equal to a squared plus 2ab plus b squared, right? Now let us notice the coefficients here. This is 1a squared plus 2ab plus 1b squared. And as you notice, this exactly corresponds to row 2 of Pascal's triangle, 1, 2, and 1. Okay, what if you have a plus b cubed? You have a cubed plus 3a squared b plus 3ab squared plus b cubed. And as you can see, the coefficients are 1, 3, 3, and 1. And this corresponds exactly to 1, 3, 3, and 1 found in row 3 of Pascal's triangle. So these things are called binomial expansions. Let me just write the term out for you. So binomial, which means there's two numbers, right? Expansions. Binomial expansions, okay? And so the coefficients of binomial expansions, if you take anything to the power of n, for example, a plus b to the power of n, the coefficients are going to correspond to row n of Pascal's triangle. And yeah, that's basically it. I hope you enjoyed the video and learned something new. Please consider subscribing. Thank you.